The next step of reaction concerns the NADH that was formed in the previous step in Krebs cycle and also in glycolysis. Now here, NADH will break down into NAD and H. The NAD that is regenerated here is now free to go back to the previous steps to bring in more H to this step. Now the H is the one that would help to release more energy. So here, H atom will lose an electron. By the way, H atoms only have one electron. So it loses an electron and it becomes an H plus and also electron. You don't need to mind about the H plus. It is the electron here that would help to release energy. Because right now, this electron is at an excited state. So this excited electron will then go through an electron transport chain. The different carriers will pass the electron around. After passing the electron around, the excited electron will start to lose its energy bit by bit. This energy that is released by the excited electron will then be used for making ATP. The process is somewhat similar to what you have learned in photosynthesis. So anyway, the electron will give out energy. This energy will be used for combining ADP and phosphate to form ATP. Now the FADH, if you still recall, was also made in the Krebs cycle. So the similar things happen as NAD. The FAD will be regenerated and the H will also undergo the same process of losing electron and then releasing energy through the electron transport chain to make ATP. So by now you probably have a question. Why is it that oxygen is needed in respiration? It doesn't seem to do anything up till now. So the NADH, if you still recall, it will turn into NAD and H, and the FADH will turn into FAD and H. So after doing this whole process in your cell, you would be having a lot of H plus and electrons in your cell. These H plus and electrons have to be taken care of, or else they will damage the cell. So here, oxygen would act as a acceptor of H plus and electrons. Eventually, H2O will be produced, and that's why in the process of respiration, water will be generated.